All right, so next we're going to be covering transformations of functions. So many functions have the graph that are a simple transformation of the graph of parent functions. So that's why we covered the parent functions yesterday, is because, or the lesson before, is because we're going to go into transformations. So we have a vertical and horizontal shifts. Let y equal f of x and let c be a positive real number. So whenever you add c, so you add a number outside of the parentheses, it's not specifically to the x, it is going to move c units up. Now, if you have a minus c, that is going to move you c units down. If you have a minus c exclusively with the x, so what I mean by exclusively, in this example, they put it in the parentheses with the x. It could be in the square root with the x. It could be in the absolute value with the x. That is going to be a horizontal transformation. So whenever they put it into the parentheses with the x, you're either going to move left or you're going to move right. Now, you do have to be careful with this one, because when you do have a minus, it's even though your negative numbers are on the left side, you want to think that it moves to the left, but in fact, it moves to the right. So it's going to be opposite. So just be careful with that. And it's only for your horizontal transformation. And so here, when it's a plus c, you're going to move c units to the left. Okay. So here we have the parent function. In this case, we have the absolute value of x. It wants us to write and graph the equation corresponding to each transformation. So here is my absolute value function. They already did the parent function for us. We don't have to draw it, it's here. So what they want us to do is they want us to translate it 5 units up. Okay, so I'm going to take this graph and I'm going to go ahead and move it 5 units up. So 1, 2, 3, 4, 5, and this would be my point. And I take every point, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and I translate it 5 units up. 1, 2, 3, 4, and it's going to be a little bit off the graph. And then it's kind of hard for me to make straight lines with this, so please forgive me. So there is what my graph looks like. This is option A, or section A, so I'm just going to put a little a there. And then I'm going to write the equation of my function. So if I move it up 5 units, it's going to be the absolute value of x, and plus 5 is going to go outside of the absolute value. All right, section B, they want us to go ahead and take this and move it 2 units down. So I'm going to go ahead and take my parent function and I'm going to move it 2 units down. So 1, 2, and I'm going to take every point and move it 2 units down. And here is what the graph would look like. I'm going to put a B here for answer choice B. And so the equation of this absolute value function would be the absolute value of x. And remember, when we move down, instead of adding, we would subtract 2. All right, the next example. So here we're moving 3 units to the right. So since we're moving, I'm going to take my parent function. I'm going to move it 3 units to the right. So I'm going to take every point. I'm going to go 1, 2, 3, and this will be my point. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And so this is what my new graph is going to look like. This is section C, so I'm going to put a little c. All right. Now we need to write the equation. So since we're moving to the right, it's going to be y equals the absolute value of x. And then the 3 is going to go inside the absolute value this time, okay? And the reason for this is that's what identifies it as a horizontal shift. Now, because we move to the right, it's going to be minus 3. So it's the absolute value of x minus 3, okay? Now, remember your horizontal shifts, it's backwards. I know that's kind of hard to remember. If you do forget, this is a good little table for you to refer back to remind you in which direction you should be moving to. All right, and then the last one, they want us to move 6 units to the left. So that is also a horizontal transformation, and then we're going to add an extra transformation. We're going to move 1 unit down. Okay, so I'm going to write the equation on my line real quick. It is going to be y equals the absolute value of x. Since we're moving to the left, it's going to be plus, and we're moving to the left 6 units, so it's going to be plus 6. I close my absolute value, and then we're going to move 1 unit down. So at the very end, you're going to put minus 1, and that's what shifts it down. So I'm going to go ahead and do that translation. So we're going to go ahead and take this. We're going to move 1, 2, 3, 4, 5, 6 to the left, 1 down. And we're going to do that for every point. 1, 2, 3, 4, 5, 6, 1 down. 1, 2, that one is not going to fit, so I'm not going to put it. 1, 2, 3, 4, 5, 6, and 1 down. Oh, I went for the wrong point, sorry. 1, 2, no, I didn't. 1, 2, 3, 4, 5, 6. I think I counted wrong, or I don't know what I did. And then the last one, 1, 2, 3. Oh, I'm taking the other graph. No wonder. 1, 2, 3, 4, 5, 6. And you're supposed to take the parent function. I do not know why I kept using option C. That's not the parent function. You have to use this one. I should have highlighted it so I could not get them mixed up. So you take the parent function, you move 6 to the left and 1 down, and that is my new graph. I'm going to go ahead and put the letter D here to show me that that was my graph for D. All right. Reflection. So your reflection happens when you put a negative either in front of the x or inside with the x. So if you put in front of the f of x, in front of your function, it's going to be a reflection across the x-axis. Now, if you put it inside with the x, you're going to get a reflection across the y-axis. So for example, here we have the parent function is y equals the square root of x. So when we want to reflect across the x-axis, we need to put the negative in front of the square root. Okay, so then what does it look like? Let's go ahead and reflect this across the x-axis. Just in case you forgot, this is my x-axis, so I need to see this one that's at 0 is going to stay there. This one is 1 unit away, so you need to count 1 unit away, and that would be your new point. This one is 1, 2 units away, so you count out 1, 2, and this would be the new one. And then last, this is 1, 2, 3, 1, 2, 3, and that would be the lowest point. And so this is what it looks like. Y equals negative square root of x. For some reason my pen doesn't want to write. Okay, there it goes. All right. So now if we have a reflection across the y-axis, so in this case, we want a reflection across the y-axis, we're going to have to put the negative inside with the square root. So it'll be the square root of negative x. Okay, so when you do that, you're going to get a reflection across the y-axis. So in case you forgot, this is my y-axis here. And so I'm going to go ahead and reflect my points. Now this one that's at 0 stays there. This one that's 1 unit away, we're going to reflect it across 1 unit away. This one is 4 units away, so I'm going to count out 1, 2, 3, 4. And that's my point. And then the last one is 9 units away. So that would be my last point. And that's what your graph looks like. And that one is y equals the square root of negative x. All right, the next one. So you have a horizontal shifts, vertical shifts, and reflections. These are called rigid transformations. And the reason that they're called rigid transformations is because the shape of the graph is unchanged. Okay, now we are going to do non-rigid transformations. And this is going to cause a change in the shape of the original graph. So when you guys did this in Algebra 1 and Algebra 2, we kind of called this, your graph was getting either narrower or it was getting wider. So, for example, if you have a number outside here multiplying with your function, or if you have it inside the parentheses with the x multiplying times the x. All right, so here for the example, the parent function that they chose to use was your y equal to x squared, which is our quadratic function. It's a parabola shape. And so I'm going to go ahead and take the parent function. I'm going to write down what these points are. So -2 is with 4. -1 is with 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay, but they already graphed that function. We don't have to graph it. Now it says make a table of values for each, and graph each of the following transformations. Sorry. So this one wants us to take 2 and multiply times our parent function, which is x squared. So that's exactly what we're going to do. On here, we have 4, 1, 0, 1, 4. So I am going to multiply that times 2. So 4 times 2 gives us 8. 1 times 2 gives us 2. 0 times 2 gives us 0. 1 times 2 gives us 2. And then last, 2 times 4 gives us 8. So I am going to graph this. So it's going to be -2, 8. -1, 2. 0, 0, 1, 2, and 2, 8. And so on this one, I'm going to go ahead and make my graph. Now, please forgive me because it's really hard to make straight lines with this stylus. There we go. And that's what it looks like. So this is what we call when our graph gets narrower. It gets a little bit skinnier. So let's try the next one. On this one, instead of multiplying times 2, we're going to take half of your function. So here we have half of 4 we know is 2. And I'm looking at these numbers, my function. Okay. Half of 1 is 1/2. Half of 0 is 0. Half of 1 is 1/2. And then half of 4 is 2. And I'm going to graph that one. So -2 goes with 2. -1 goes with 1/2. 0, 0, 1, 1/2. And then 2 goes with 2. And so our graph gets a little bit wider. Just a little bit. All right. So then the next one says make a table of values and graph each of the following transformations. So this one's a little bit different, because instead of multiplying the 2 times on the outside, it's multiplying the 2 times the x first. So if we look here, we multiply 2 times -2. That gives us -4. Okay, I'm plugging these into the equation just in case you're confused. And so -2 times 2 is -4. -4 squared gives us 16. -1 times 2 is -2, and 2 squared is 4. 2 times 0 is 0, and 0 squared is 0, 4, and 16. And so we can't graph these points here because it's going to come off the graph, so we're just going to have to do -1, 4, 0, 0, and 1, 4. And we make our graph. And so this one seems like it's even skinnier or even narrower than the last one. So if we look, just to move the paper over, you can kind of see how it's even narrower than the last one by putting the 2 inside with the x. And the reason for this is because we have to multiply times x first, and then we have to square it. All right, the next one we have 1/2 x squared. So here we have 1/2 of our x value. So half of -2 is 1, or -1, and -1 squared is going to give us 1. All right, half of -1 is -1/2, and then -1/2 squared is negative, oh no, not negative, sorry. 2 negatives give you a positive, so it's positive 1/4. Half of 0 is still 0, and 0 squared is still 0, so that doesn't change. And then half of 1 is 1/2, and 1/2 squared is 1/4. And then last half of 2 is 1, and 1 squared is 1. So I'm going to graph that. So -2 goes with 1, then we have 1/4 here, 1/4, and then back to 1. So this one gets even wider than the last one. Sorry, that wasn't a pretty graph. Okay, so this one, it's a little bit different. When the number is inside with the x, then you're going to have to perform that operation after you multiply times 2. And this one, you just go ahead and multiply it after you're done. So here it's just like a little conclusion. So if you have your function, all you're going to do is take your f of x, which is really your y value, and you multiply it times c. Or you take your function, you multiply it by 1/c when it's a fraction. And so when you do multiply it by c, it gets narrower. And when you multiply it times 1 over c, it gets wider. Now this one, I wish we could write a rule, but we can't because everyone's going to be different. So in our example, we had an x squared. So first we had to multiply the number and then square it. You're going to have situations where your parent function is the square root of x. So if you put a number in here with the x, you're going to have to take the square root of that number. So that's why I can't give you an exact transformation for that one. But that's the last one that we're going to cover. Now, I am going to go over to your Delta Math so that you can get an idea of what your assignment looks like and what is expected of you on the assignment. So here's the first one. It gives us negative 2 to the x power minus 5. So we need to see the transformations. So here, if we had our exponential function, that's a parent function. And so we have this negative here, and whenever the negative is in the front, remember, not exclusive with the x is up here and it's not in there with the x. Let me erase that little dot. Okay. That means that we're going to have a reflection, and if you forget, go back to your notes. So sorry, I have a lot of stuff open. Go back to your notes and see, okay, where is the negative? Okay, the negative's in front of the x. That means that we are going to have a reflection across the x-axis. Just in case you forget, refer back to your notes. So back to here, that means I'm going to have a reflection across the x-axis. So to get this to reflect across the x-axis, you are going to take your function and you're going to, instead of it being up here with the 8, you're going to reflect it down to the negative 8. Okay. So I did that. That's my first translation. But not only does it have that, it has this minus 5. So minus 5 means that we're going to have to move this graph down 5 units. So I'm going to take this point here and we're going to move it down 5 units. I'm going to take my little arrow. And instead of being here at 0, 0, we're going to go 1, 2, 3, 4, and 5. So that's how you move the whole graph down. And then hopefully I did this correct. I think it should be good. Let's see. Submit answer. Are you sure? Yes, and then it's correct. So let's try another problem. Okay, so here it has our, sorry, let me erase this. It has negative absolute value of x. Now remember, in case you forget, don't be shy to check your notes. So let's go ahead and check our notes. When the negative is inside with the x, you're going to have a reflection across the y-axis. So I'm going to go back to my Delta Math. And then if I'm going to reflect this across the y-axis, it ends up being at the exact same spot. Because this point, if I reflect it to this side, it's on here. I reflect this one over here, and so on. So we can't really reflect it across the y-axis because it just ends up being the exact same graph. So I'm going to submit my answer. Are you sure? Yes. Okay, that one was too easy. Let's try one more. All right, so this is a cube root of x minus 5. So the only translation translation I have is this minus 5. So because it's a minus 5, that means we're going to have to use 5 units. We're going to move it down. So I'm going to take right here the little green dot. That's how I'm going to move it up and down. And we're going to take it 1, 2, 3, 4, and 5. And that's where my new graph is going to be. And I submit my answer. Are you sure? Yes, I'm sure. And it's correct. Okay, let's go ahead and take a look at the level 2 problems. So on here, this is where we're bringing these numbers here. So we have a translation here and a transformation. So we're going to go ahead and perform, I don't think it matters which one we perform first, but this plus 1 is going to tell me that I'm going to move to the left 1 unit, okay? This one's going to tell me that I'm going to go ahead and take 4 and multiply it times my function. Okay, so f of x really means y. I'm going to go ahead and take 4 and multiply it times my y value. I'm going to go ahead and do that one first. So here it's at 1, 1. And we're going to multiply 1 times 4, and that gives me 4. Okay, and it actually moves a whole graph. So this one that was down here at 8 ends up going all the way up here. So it moves that one already for you. So we already did that. And now we're going to take the whole graph and we're going to move it to the left one. So we are going to go to the left one. And then let's go ahead and submit our answer. Are you sure? Yes. And it is correct. So let me go ahead and do another one like this. All right, I think it is going to be a little bit easier for us to multiply the number first. Now this one, we are going to take the 3 and multiply times the x to the third power. So let's see. Here's my function. Here it's 1 is at 1. So instead of being right here at 1, I'm going to multiply 1 times 3 gives me 3. So this point moves there. Now I have this plus 1. Now this plus 1 means that it is shifted up 1. So I'm going to take my little green dot and we're going to shift it up 1. And that's how you shift it. And we submit our answer. Are you sure? Yes, I'm sure. All right, let's go ahead and look back at the last section that you guys need to do. Okay, so this one is pretty crazy. It says the graph of f of x is a solid black graph. So that's your original function. And then it says which represents the dotted graph. So here's my dotted graph. So I'm going to see, let me get my drawing tool. So let's see here. What would be a good point to kind of verify with? I think probably this one right here. So this is at 2, -3, and it moves over to this point right here. That's like an equivalent point. So if I check, it moves 1, 2, 3, 4, 5 units to the left. And then it moves up 1, 2, 3, 4. It moves up 4. So because we moved up 4, we're looking for something that's plus 4. And then because it moved to the left 5, remember it's opposite on our horizontal translation. We're looking for something that has plus 5. So if we look down at our examples, the one that has plus 4 and plus 5 would be this one. And that's the only one actually. And remember, your vertical translation should be outside of the parentheses. And your horizontal translation should be inside with the parentheses. So this one should be our answer. And then we submit answer. Yes, this one was kind of a hard one because they didn't give us the parent functions that we're used to. They do show you how to translate. Okay, let's go ahead and do one more example of this. I know the video was kind of long, but I wanted to describe this in a lot of detail. All right, so here we have this square root function. And if we notice, it all of a sudden flips around, and instead of curving up, it curves down. So that means we're going to have a negative. And it's going to be in front of our function, whatever our function is. I don't know what it is. Because remember, when the negative is inside with the x, that would reflect it across the wall. And then this point here ends up shifting to the right 1 unit. Okay, so because it shifts to the right 1 unit, we are going to subtract 1 to the x, but it has to be inside with the x. Okay, so I'm going to go ahead and erase that parentheses, and I'm going to put -1. So that's what we're looking for. So if I look here, that is going to be this answer choice, submit. Are you sure you want to submit this answer? Yes, and that's it. So thank you guys for watching. We will see you guys next time. Bye.